So yeah, we're running the Generalized Racing Intelligence competition. This is the third iteration of GRAIC, and each year we've been co-located with CPS Week, and this is organized by people from both the University of Illinois as well as the University of Michigan. So just a quick overview of the program again. We're going to do a quick competition overview and what the competition is going to look like. Then we'll talk a little bit about the current GRAIC framework and then have a Q&A session. So for the competition overview, why exactly are we doing GRAIC? Well, there's this quote by Henry Ford that says, auto racing began 5 minutes after the second car was built. And so you can see here, there's a lot of different races that were held throughout history. But as autonomy kind of becomes bigger and bigger, we start having these autonomous races like the Indy Autonomous Challenge, Alpha Pilot, the AI robotic racing, as well as F110. So what we did is we introduced GRAIC as another race that focuses on benchmarking decision and control algorithms. So here's a schedule for GRAIC. January 31st, we had our beta platform release. And so with that, you can go ahead and install GRAIC locally on your own machine, or you can go to the AWS image that we've provided, which should make installation easier there. Today, we're having our info session and any feedback you might potentially have about our beta platform. On March 17th, we're going to release our final platform, and at the same time, our pre-submissions will open. So pre-submissions are a way for you to submit your controllers. These won't be the final controllers that we end up racing, but it's a way for us to evaluate that our automated testing pipeline is able to take the controllers that you submit and properly give back the metrics. And then we'll give you any sort of feedback that sort of comes along with that pre-submission, so you can use that to improve your controllers over the entire time that our pre-submissions are open. On March 31st, we're going to open our final submission page. So for the final submissions, you can submit multiple final submissions, but in the final competition, we're only going to race the last submission that you have submitted to our final submission page. And so just one thing to note is that our pre-submissions and our final submissions are not the same. So be sure that you submit at least one controller to the final submission page to be a competitor. On May 2nd, we're going to close our submissions, and then we're going to hold all of our final races. So when we release the beta platform, this comes with a couple different races that could potentially be used in the final races. But on May 2nd, we're going to have a new set of races that we're going to test your controllers on. And then we're going to collect all the metrics from those races, and then we're going to score your final controllers. And then on May 9th, that's when CPS Week is going to be held. We're going to have our final results announced. And then we're also going to have a live event, which should be hybrid. So you can attend virtually, and sort of we'll have another presentation of how the competition went, as well as some of the competitors talking about their submissions. And then we'll release those final results at the same time. So just some quick overview of the competition logistics. So the input to our competitor, so you're going to provide the controllers here, and then each controller is going to get some sort of perception input from the perception oracle that is going to provide the ground truth perception information about the vehicle's surroundings. And so this is the only information that your controller is going to be given at any point in time. So each of the tracks that we release will have some unknown static obstacles and dynamic scenarios. And at each point in time, the perception oracle will return some subset of that track information around the vehicle. The controllers are going to be run across multiple different vehicles and tracks. So we have different shaped tracks, as well as different types of vehicles that these controllers will be used with, which is where the generalized racing intelligence part comes in. So your controllers that you submit should be able to be run with any of the vehicles that we could potentially use in this competition. The metrics from each of these races are then collected, and then scores are assigned based off of what the metrics that are collected in each run of the race. And then these scores will be updated to our leaderboard as the controllers are submitted. And then you can just kind of keep track of how well your controller is doing compared to other competitors. And then at the end of it all, the controller that has our highest score will win the competition. So there's two tracks in GRAIC. We have a single agent track as well as a head-to-head track. So in the single agent track, each controller is raced across the same set of race configurations, where our configuration is defined by the race track, the scenarios, and the vehicle. So the scenarios can consist of pedestrians crossing the street or of different vehicles that are trying to navigate the same road. These aren't controlled by any other controllers, just like the baseline controllers that are given with Carla. So they don't really react to your vehicle as they go by. The metrics from these races are the metrics from the single agent races, not head-to-head race, but the single agent races are collected and then the scores are assigned, and then the controller with the highest score is going to win. So then on the head-to-head competition track, each controller is going to be raced against every other controller. So we'll have two racing agents in one track, and then each one is going to be running a different controller, one of your competitor's controller. And then the metrics will be collected from there. So like how well each controller performed against each other, and which one won that specific race. And then based off of how well each controller compared against all the other controllers, that's how we're going to assign the scores for our head-to-head races. So if you're interested in participating in GRAIC, be sure to sign up for our emails. This QR code will take you to the link that signs you up for our mailing list. And then we will send out an email once the registration for the final competition begins. You'll also get information to our forum. If you go to our website, you can post questions on there, or feel free to email us at our email address, which is also shared on the main website. So and now Jan will talk a little bit about the GRAIC framework.
Thank you, Christina. So right now I'm going to talk a little bit about our competition. So GRAIC competition has been going on for a few years, and we've been achieved quite some success in the past few years. Last year, we have like GRAIC 2022 have 16 submissions during the CPS week. We have received a controller submission from 5 teams. 3 of them are from university groups, and 1 of them is from a company. We also achieved some outreaching activities, for example, doing some simple demo for engineering open house and summer camp. Those, by the way, all those submissions from the past has become benchmarking for testing and research resources as well. So what does the GRAIC infrastructure look like? Basically, we offer you, we provide you with scenarios and maps so that your controller can race on different conditions in the car simulator. On the top left, you can see this is a scenario that your controller will be racing on. You can see there are some dynamic obstacles, static obstacle, and there's a track you need to follow some waypoints to achieve the end goal. In the top middle part, you can see this is the head-to-head races we held last year. So you will be racing against other controllers like after the submission deadline. And we also have provided several different vehicle models. So you want to make sure your controller is not just overfitting to one of the vehicle model, but can be generalized to different kinds of vehicle, and also generalized to different kind of tracks, not just simple like circle track, but also complicated track with many corner and turns. On the top right, you can see this is a figure illustration of how the overall GRAIC testing works. Basically, we will provide a wrapper function to you that will get the data from the simulator, for example, track information, scenario, the obstacle information, and those are ground truth information provided to you. So your controller will have those ground truth, obstacle, land, location information, and your controller's task is to generate the optimal control values. For example, what's the turning throttle, brake, and steering values you should do. So based on those, the trajectory of your controller, we will estimate the states as well and get you a score. For example, if you reach the destination the fastest, you will have a better score. If you glide, you will have if you glide a lot, you have a worse score. So this is an illustration of how the GRAIC testing pipeline works. For participants, for participants, you can probably only see 2 different websites. On the top left is the submission website where you will be able to submit your controller file through a public website. And on the top right, this is a leaderboard site. So after we finish testing your controller, you will be able to see your results like videos, logs, and score ranking on the leaderboard websites. Everything happened in the middle. The middle block is happening on the backend, which is what we will automate the testing pipeline. So upon receiving your controllers from this website, we'll automate launching the simulator, loads different kind of tracks, race configuration, different kind of scenarios, different kind of vehicle models, execute your controller, and do the evaluation. The last step of the testing pipeline is just to email you the results with the logs of of the performance of your controller. So this year we have done a few improvements. On the top right, you can see this is a demo video of like the latest version of GRAIC. The biggest improvement we did is to remove ROS so that it can be everything can be executed much faster. We also upgraded our Kara simulator and scenario runner version to 0.9.13, which the Kara side claim to be a more deterministic version of the simulators than before. We also plan to provide some improved visualization for you so that it can help the developers write the controllers better. We also are inventing some new racetrack so that your controller can be raced on different and more complicated tracks. And based on all those changes we make, we also redid the AWS image, and I believe it's already posted on the AWS public community, so people can try and use AWS instance to run GRAIC 3.0. So that's the that's the presentation for today. Is there any questions? We can address that now. And I can also show you some videos of some of the controllers running on the latest version. More demo videos here. So you can see the light blue gates it's kind of like the objective points you have to reach, and there will be some scenarios like cars in front of you that you will need to navigate through, like the car just did going through the narrower place. And you can see the score on the button, 109, 104, which is the time to finish. Yeah. So that's the overall of how it looks like with the current simulated, GRAIC version.